the beginning of a long list of requirements. Getting anything into space requires huge amounts of power and lift. Engineers knew the Lunahod must be strong, yet extremely light. So they even had to develop their own metal, an aluminum-titanium alloy.
For us, creating a mechanical device that could travel over a specific surface wasn't really a problem. The difficulty was in creating a device that met all the technical requirements.
Their mechanical devices were extremely clever, and so they had a much more of a classical engineer's approach to it. Try it, build it, see it, test it, doesn't work, try it again, do it this way, and if we only get 75%, that's okay. Next time we'll get 95%, and then the time after that we'll finally have full success. They were much more willing to have a systematic, ongoing approach.
In 1964, just 2 years after the initial sketches were drawn, engineers were testing their first prototype. Equipped with 4 drive wheels, this strange robot turtle took its first few steps.
We placed a Japanese video camera on it and controlled the machine from a distance using a television. We then started thinking about the remote control guidance system.
To simulate conditions on the moon, a hangar was built called the Lunadrome. From a control vehicle alongside, 2 men operated the test vehicle on a track strewn with obstacles. The car had 8 drive wheels with independent suspension. Amazingly, it only required 3 to remain operational. But whenever Alexander Kamergian solved one problem, a new one seemed to crop up in its place. For example, on Earth, when 2 metal parts are in contact, a film of oxide forms at the friction points, acting as a lubricant. In space, the 2 parts simply fuse together. The solution? The team invented a fluoridated oil, which would not evaporate in a vacuum. Still, one huge question remained. Would it all work on the moon at just 1/6 the Earth's gravity?
Sergei Korolev offered to launch a satellite just for us so that we could test our engine compartments and the mechanics in a gravity-free environment. In the end, we didn't need a specific satellite because we found room in an existing satellite already scheduled to launch.
The Lunahod was now ready for full-scale tests. Secretly, the engineers transported their prototype to the Kamchatka Peninsula, 9 time zones away from Leningrad. Geologists felt this volcanic landscape found in the far east of Russia would be similar to the surface of the moon. They tested the automated control systems and scientific equipment. This tool, called a penetrometer, would measure the density of the lunar surface.
It was not, of course, an absolute replica of the lunar surface. What was important were the characteristics of this surface, its capacity to detect the reactions of the motors and chassis to these requirements. And this was the most important thing.
In 1965, the prototype was complete. Sergei Korolev moved the entire operation to Moscow, to the Lavochkin Institute. Rocket scientists there would be constructing and testing the lunar landing module. Executive Director Georgy Babakin oversaw this phase of production.
Babakin's group sent us these instructions. Make sure the Lunahod goes down the ramp to the lunar surface and drives at least a few meters. That's already something, and everyone will be grateful to you. But we also knew that if the Lunahod only drove a few dozen meters and stopped, we wouldn't be spared.
They wouldn't be spared because for the Kremlin, winning the race to the moon was imperative. But in Florida, at Cape Canaveral, the Americans had already successfully launched the largest rocket ever built, the Saturn V. NASA had huge resources and the backing of presidents. Soviet scientists, on the other hand, pinned their hopes for a moon landing on their own giant, the untested N-1 rocket. But with each test launch, that hope never lasted more than 50 seconds. It was looking more and more like the early glory days of the Soviet space program were coming to an end. Then, in January 1966, things got even worse. Sergei Korolev, the man who masterminded the country's first successful decade in space, died during routine surgery. But he died a national hero. Korolev was given a state funeral and is buried at the base of the Kremlin. For the Soviets, though, plans to put a car on the moon did not die with Sergei Korolev. So many had devoted so much to the Lunahod, and they were determined to succeed. (1966). The father of the Russian space program, Sergei Korolev, died unexpectedly. The Russians' secret project to construct the Lunahod was now in the hands of Georgy Babakin. His team was working tirelessly.
We fixed up the offices so that we could sleep there. We brought in mattresses, sheets, blankets, and called that part of the plant the Charmash Hotel, because we usually manufacture chars, tanks, hence the Charmash Hotel.
The builders pushed themselves hard. The stakes were high, and the project filled with unknowns. On the moon, temperatures fluctuate wildly, so engineers designed a device they nicknamed the frying pan, a door equipped with a solar panel. During the 2-week lunar day, the open panel provided energy to the wheels and instruments. When the lunar night approached, and temperatures can drop to minus 275 degrees Fahrenheit, the lid closed down to shut out the cold.
Lunaco designed itself the thermal control system with the radioactive heater and the lid that shuts and opens, which also serves as a solar collector during the day. That thermal design was very ingenious.
A tiny nuclear reactor powered a generator fitted to the back of the Lunahod. During the lunar night, which lasts 2 Earth weeks, the shield would close down and a generator would heat a gas contained in a pressurized compartment. To withstand daytime temperatures approaching 320 degrees Fahrenheit, the Lunahod utilized a never-before-tried ventilation system. This was just one of the rover's many innovations, and each had to be tested and retested. And there was one more major hurdle to overcome: finding people with the skills to drive a car from a distance of 250,000 miles. Once again, the best place to look was in the military. By late 1966, 45 officers had been chosen secretly. A series of tests whittled that list down to just 14. It was only then that the candidates learned they would be driving a car on the moon. Vyacheslav Dogvan, shown here in a rare 1967 film clip, was one of the 14. He recalls the experience.
Before us, they had tried to use aviators, tractor drivers, car drivers, and even cyclists. They selected men who knew how to assess a situation rapidly and who could memorize and reproduce the situation immediately.
As drivers competed for the coveted top spots, they underwent intense training. They used a control mechanism developed by the Germans to guide bombs, a joystick. Over and over again, they repeated maneuvers they would need to perform once the rover reached the moon.